Hello students, good morning. Welcome back to the new YouTube channel, new YouTube video on my interest use of machine learning or from the first year engineering student. In video, let's we discuss the machine learning life cycles. Believe me, it's a very important topic while we starting your machine learning journey. Basically, in this lecture, we will discuss the each and every phases of machine learning cycles with an simple, clearly example or it's an understandable. When you see this video, you are eligible for the what the machine learning actually do in his entire journey. So please watch the video carefully and now start our video. So first of all, the machine learning development life cycle is the complete process of building, training, testing, and deploying a machine learning model. Yeah, you know that it's a life cycle. So you know that life cycle. It's a complete process of building, training, testing, and deploying a machine learning model. Yeah, example, suppose first of all you born, then you enter in a kid state, then after that you become an adult, then you you get an married, then you have an family, student, you are student or then you become an old and then death. So it's an life cycle of the human being from beginning to the end. So likewise, machine learning also have a life cycle from its beginning to its ending. So possibly it has a 9 steps. It's maybe changes many more. Sometimes you see it as 8 steps, sometimes 9 steps. But yeah, I will try to explain each and every step in very clearly. So let's discuss the first step. So problem framing. Problem framing is one of the most important or first step in the machine learning life cycle. Problem framing is also called as problem understanding. Now the definition. Understanding what problem needs to be solved and defining the goal of the machine learning object. So when we start our machine learning project or uh, machine learning journey to solve any projects, you know that what you would perform or what task can you solve. So first of all, problem needs to be solved and defining the goal of machine learning project. It's a very important concept. So yeah, this is a very important concept. Explain in this step we decide what prediction we want, what type of data is needed, and whether ML is required or not. Suppose this is a problem, and this is your goal. So your goal is must to define before you start our project. From this goal, you understand your problem statements very clearly and start work regarding to this project goal. Now the second one step is a data gathering. We will discuss in the day. I know that we step, but we discuss the data engineer, data analyst, and data scientist. So this role is also part of a machine learning life cycle. Now see that this is a second step data gathering. Data gathering which role has a main goal of the data gathering. So data engineer has a main goal for the data gathering. Now for predicting or developing an any machine learning model, you require to data. When you have no data, then your machine learning can't work. So that's why data is most important. Collecting relevant data from different sources for training the model. And you not give the your data, so how your model train? So machine learning model learns from data. So collecting good quality data is very important. See here, collecting good quality data. Good quality means clean data that are used to do machine learning model. It's not affect our machine learning model. It's increase your performance. Then sources, databases, CSV files, APIs, sensors, websites. We can also gather data using websites or performing the web scraping. Yeah, we also discuss these problems in the next videos. This it's a very easy concept. We can also discuss the databases. Yeah, this is an our second step data gathering. Now third one is an data pre-processing. So what is meant by pre-processing? Cleaning and transforming raw data is called as pre-processing into a usable format. Usable format means we can apply directly machine learning algorithms to the data sets for predicting the result. So real world data may contain the when suppose you gather an data, it's also may contain or may not contain, but most of the times it contains missing values, duplicate records, outliers, text data. Suppose missing value is it's one of the disadvantages of our data. When your data has a missing value, your model can't perform it because machine learning model can't expect null values. Duplicate values, your model train on a noise data, duplicate record, so not performs well. Then outliers. Outliers means suppose this is our data set. Suppose this is our data set. Many data has an in this around this circle or likewise here. But some of them are here, some of them here, some of them here. Yeah, this is an outlier. This is an outlier difference. It's badly affect our model performance. So it's must find out and remove it is required for improving our model performance. And then last one is text data. Text data means suppose an sex, a male or female, and then other category. But your machine learning model can't expect the categorical data. You must convert it into the numerical data. So your model performing the mathematical computation on it and try to improve your performance. So it's an very important steps in the machine learning life cycle. Now exploratory data analysis. Fourth one is exploratory data analysis (EDA). EDA is an important steps or important concept in the data analysis. Now what is meant by EDA? Analyzing and visualizing data. We discussed that we uses the Python libraries like and matplotlib, cborn to understand pattern relationship. We can also use the outside outlier. We can also use the tools like Power BI, Tableau for the analyzing and visualizing data to understand pattern relationship. EDA helps us understand which feature are important. Suppose you have 1 to 10 features. From these 10 features, we and basically, we can't provide 1 to 10 pieces. All of them are to the machine learning models. We find out the which feature are most important, which features are most affect to the target column. So these features are used to improve our performance and data distribution, how your data is distributed, and correlation between columns, how one column is correlated to the another column, and then presence of outliers. It also used to presence of outliers. For presence of outliers, we can plot the box plot. There is a very easy steps to detect an outlier in our data. So yeah, expert data analysis is also a very important concept phase in life cycle. Now the feature engineering and feature selection. Creating useful feature and selecting important feature from the model. Feature engineering, creating new column from existing data. Feature engineering is basically concept of suppose you have an data set. Suppose you know that Titanic is a data set. We also discussed these data sets in the future video. So Titanic data set has two columns. First one is parent child, and second one is sibling like I. So it has one, two, three. Suppose. So we create a new column called family and adding them to the this and creating a new family size. So this family size it's a very important column for our model prediction. So likewise we create a new feature from different your logical idea. You have an required more your logical idea, thinking ability to construct this type of columns. In feature selection, suppose in sometimes you have a higher dimensional data sets, one to basically suppose 100 column. So we can't provide all 100 column to our machine learning model. But when we provide these columns, the machine learning problem becomes lengthy, slowly, or not performing well. So model selection is one of the most important concepts in this. We can also use PCA, LDA algorithm for this. We will discuss it in the future videos. So tension mat lo. We will cover all each and every topic. So after that, model selection. It's one of the best. Each and every concept is each and every concept is important. But when we go to the airport, then priority of the steps is increasing. Choosing the appropriate machine learning algorithm for the problem. Suppose your data set is an categorical data set and you choose logistic regression. It's not in a good way. Suppose your data is on a continuous value. You choose logistic regression. You must choose linear regression for solving this problem. Suppose, yeah, this type of choosing appropriate machine learning algorithm for the problem. Different problems require different models. Understand this. Different problems require different models. Yeah, machine learning has an multiple algorithms and also have an multiple problems. So each problem is required different models. Not I mean not this. Different problems different requires different models. So linear regression problems, decision tree classification problems, k-mean clustering problem. So the choices depends on data size, accuracy, and most one of these from problem type. What's our main problem type? So it's an easy step. You when we know the concept of in our machine learning journey, we easily understand model we can, which model can we perform based on this problem statement. So then the model training. After that, choosing the model, it's required to train our model from the existing data. So teaching the model using training data, we divide our data into two parts. First one is training part and testing part. Training part are used to train our model. It means a learn or teaches our model how react when this type of data is come. And then test data. Test data are used to test the prediction of our data. The algorithm learns patterns and relationship from the data. So after that, model evaluation and hyperparameter tuning, checking model performance. Suppose you provide this value and your model gives this value. So checking the comparison between two values and finding out the performance between them, finding out the error values between them. So this is our concept of model evaluation. And hyperparameter tuning, it means we can use another technique. Suppose this has and this shows some difference. So our models try to improve our performance like this. So basically this and this are shows 90% similarities. I am not saying 100% but showing 90%. But before it's this is an 70%. So your models improve performance 20%. It means your model predicts 90% accurate data. So this concept is a hyperparameter tuning. We also learn these techniques for the improve the model performance. And the last one step is a deployment. After completing your machine learning model, checking its uh, checking its accuracy, it's time to deploy your model. When you not even deploy your model, it's not an work anyway. So deploy in real time, then it's an useful for any other and use an easily ways. So deploying our model, we basically use this the beginner as a streamlit, then fast API. And it's a very easy concept for deploying our model. So and then We are discussing the block diagram. We will discuss these steps. Also, this step will include this problem definition, then data collection. Each steps perform one after another. See here, this arrow goes here, then this arrow goes here, then this arrow goes here. Now the data cleaning and pre-processing, exploratory data analysis with concept of data analysis, then feature engineering and selection, then model selection, then model training, then model evaluation and tuning, then model deployment, model monitoring and maintenance. After deploying the model, it's a real-time model. You must require to model monitor and maintenance of our model. So yeah, let's go. I will. Yes, I am covering the all phases in life cycle, machine learning life cycle. So if you have if you have any doubt regarding to our machine learning, you feel free to reach out me. I am able to. I am pleasure to able to solve your problems. So yeah, thank you for watching my videos. Yeah, later, bye.